All right, find the solution set for a quadratic trinomial, except this time the quadratic trinomial has a leading coefficient a that is not equal to 1. So we've got a x squared plus bx plus c, where a is not equal to 1. Everybody, I don't want to do this. This takes too much work. Well, it's part of life. Okay, so first things first. The answer is going to be the same for all the 8 problems. Can I factor something out of 2, 19, and 24? No, they're not all divisible by 2. Oh, that 19 is not divisible by 2. Okay, that's fine. Well, if that's the case, then my A is 2, my B is 19, and my C is 24. I'm trying to find all the values of x that make this whole thing equal 0. So let's do that. Okay, so if we figure out what multiplies to AC, in this case, 2 times 24, that'd be positive 48. Two numbers that multiply to positive 48 and add to 19. Okay, let's do that. Okay, so I figured out the combination, so pause the video if you want to do this on your own. I'm going to give away the answer in 5, 4, 3, 2, 1. Okay, well, it's a positive-positive combination because a positive times a positive is a positive. Two positives added together make more positive. That and if you need more time to figure it out, pause it right now. But that winning combination is positive 3 and positive 16. Because 3 times 16 is 48, but 3 plus 16 is 19. So that's the winning combination. Because A is not equal to 1, I can't just jump into the binomials. I have to split that middle term. So in particular, this middle term can get split into positive 3x and positive 16x. Now we're in business. Now, for the final step in the factoring process, we put the ax squared in the top left, we put the c in the bottom right, 2x squared here, 24 there, and I'm just going to put the split bx's wherever. Plus 3x plus 16x. Okay, now then, cover the right column. Can I factor something out of 2x squared and positive 3x? Well, 2 and 3 can only be divisible by 1, so that doesn't really help me. But x squared and x have an x in common, so I'm going to factor out that x. Now that I've got 1, if this helps you, put 1x, that's fine. 1x times what is 2x squared? 1 times 2 is 2, so this would be 2x times x is 2x squared. X times what is positive 3x? That would be positive 3. 2x times what is positive 16x? Well, positive 8. And just to check my work, is 3 times 8 equal to 24? Yes. So therefore, this factors into 2x plus 3 times x plus 8. This took a long time to do. Oh well. 2x plus 3 times x plus 8. Okay, sorry, but started to space out the parentheses right there, but I just wanted to make it really spacious so I didn't have to scrunch it together. I've got a multiplication problem. I like a multiplication problem, especially when the output is equal to 0, because now I get to use the zero product principle. If I've got 2x plus 3 times x plus 8 is equal to 0, I'm going to split that into 2 cases and solve for x. So either 2x plus 3 is equal to 0. Oops, slipped off the book there. 2x plus 3 is equal to 0. Or x plus 8 is equal to 0. So now, let's solve with the right problem. X plus 8 equals 0. Well, that's pretty simple. I'm going to subtract 8 from both sides. So one of the solutions is very, very nice. X equals negative 8. I'm very, very happy. However, the other side, I'm not so happy. 2x plus 3 is equal to 0. I'm going to subtract 3 from both sides. Oh man, I got to work with fractions. 2x is equal to negative 3. So then I need to divide both sides by 2 to get x isolated. And even though if you want to, you can leave this as negative 3 halves. I'm not going to get mad at you. But if you're a decimal person like me, I personally would like to do negative 3 divided by 2, which is negative 1.5. So either way, you can pick either one of these two for the other solution, and I'm happy. So negative 3 over 2 or negative 1.5. But the other solution is x is equal to negative 8. And we did that with the goal of figuring out all the x values that make the output equal to 0. You can plug it in for yourself. Moving on to problem number 2. 5x squared plus 28x plus 32 is equal to 0. Well, I can't factor anything out, so I'm going to jump right to it. A is equal to 5, B is equal to 28, and C is equal to 32. I had a bit of trouble with this problem myself because I always try to make sure that all the problems are done properly before I video record them. So I had to do this to see, hey, is there a mistake in this problem? And let's see. So 5 times 32, that'd be AC, that'd be positive 160. And B is positive 28. And I had to think to myself, is there a combination that multiplies to 160 and adds to 28? I had to take my time, so I know that you do too. Please pause the video and do this independently. 5, 4, 3, 2, and 1. Okay, so I ran through this list of numbers. I did 1 times 60, but 1 times 160, and 1 plus 160 is 161. 2 times 80 is 160, but 80 plus 2 is 82. 4 times 40 is 160. 4 plus 40 is 44. 5 times 32 is 160. 5 plus 32 is 37. Okay, and then it couldn't be divisible by 6, 7, but it is divisible by 8. So this one took a while for me to do. 8 times 20 is 160. 8 plus 20 is 28. So there is the winning team. And I wish that we could go right into the binomials. But this is a split the middle term problem because the A is equal to 5, not 1. So therefore, I'm going to split that middle term into positive 8x, positive 20x. So now I've got the expression 5x squared plus 8x plus 20x plus 32. Now I split the middle term and I'm going to put it in the rectangle. I've got 5x squared in the big fella. I've got positive 32 in the small fella. And the split bx's can go in either one of these two diagonal spots. I'm just going to put positive 20x here and positive 8x here just because. So I cover up the right column. Can I factor something out of 5x squared and 20x? 5 and 20 are both divisible by 5. And x squared and x are both divisible by x, so I can factor out a 5x this time. 5x times what is 5x squared? Okay. Well, 5 times 1 is 5, and x times x is x squared, so 5x times 1x is 5x squared. All right. 5x times what is positive 20x? That would be positive 4. X times what is positive 8x? That would be positive 8. Check my work. Is 8 times 4 equal to 32? Oh, you betcha. So therefore, this is how we factor it appropriately. So I'm going to put x plus 4 in the left factored part, and then 5x plus 8 in the other. So now I've got a multiplication problem. I like a multiplication problem, especially when the output is equal to 0. So that means I can use the zero product principle to solve for x. So now I'm going to split the two binomials into their respective cases. Either x plus 4 is equal to 0, or, let me just get that out of the way, x plus 4 is equal to 0, or 5x plus 8 is equal to 0. So let's start with the left side. X plus 4 is equal to 0. Let's solve for x here. So now, if I subtract 4 from both sides, I get x is equal to negative 4. That's the only solution, right? Nope. I want full credit, so I need to do the other side as well. So 5x plus 8 is equal to 0, so I'm going to subtract 8 from both sides. So now I've got 5x is equal to negative 8. 5x equals negative 8. I'm going to divide both sides of the equation by 5. Now, if you're okay with a fraction, you could write this as negative 8 over 5, because that can't be reduced. That's fine by me. If you're a decimal person like me, that 5 goes into 8 one time with 3 remaining. So that'd be negative 1.6. Either one of these two would work. I'm happy with the fraction, I'm happy with the decimal, but I also want to see x is equal to negative 4. So that is how we solve for the quadratic trinomial when it's equal to 0. And we've got x squared and x, where there's two solutions. Okay, moving on to problem number 3. All right, put this in the recycling bin. Thank you. Number 3, 5x squared minus 32x plus 12 is equal to 0. Can I factor something out from A, B, and C in this case? No. A is not equal to 1, 2, so I got to do that split the middle term and rectangle thing. That's a bummer. A is equal to 5. B is equal to, this time negative 32. And C is equal to positive 12. So I'm trying to figure out the winning team that multiplies to A times C, in this case 5 times 12, and adds to negative 32. So what two numbers multiply to positive 60 and add to negative 32? Okay. Pause the video if you want to figure this out on your own, because otherwise I'm going to give the answer in 5, 4, 3, 2, and 1. Okay. Well, if it multiplies to a positive and adds to a negative, the combination needs to be negative times negative, because that would multiply to a positive. And two negatives added together would form more negative. So if you want to know the awful truth of what multiplies to 60 and adds to negative 32, that combination would be negative 2, negative 30. Negative 2 times negative 30 would multiply to 60, but negative 2 plus negative 30 would be negative 32. We have a winner. But we cannot split it into two binomials yet. We need to split that middle term. So specifically, 5x squared minus 32x plus 12 splits that middle term into negative 2x and negative 30x. Now we put the pieces into the rectangle. So 5x squared goes in the top left, positive 12 goes in the bottom right. It doesn't matter which of the split bx's go here. So I'm going to put negative 2x here and negative 30x over here. Okay. Cover up the right column. What can I factor out of 5x squared and negative 2x? So now, 5 and 2 don't have anything in common besides 1. But x squared and x have an x in common, so I could factor out 1x. Now, 1x times what is 5x squared? Well, 1 times 5 is 5. X times x is x squared, so this needs to be a 5x. X times what is negative 2x? Well, 1 times negative 2 would be negative 2, and x, it doesn't need another x, so that'd be x times negative 2 would be negative 2x. Okay. 5x times what is negative 30x? And that would be negative 6. Check my work. Is negative 6 times negative 2 equal to positive 12? Oh, you bet. So therefore, we've factored this correctly. Now, let's factor it out. So one of the dimensions is 5x minus 2. The other dimension is x minus 6. And that whole thing equals 0. Now then, for the thousands in attendance, what do we need to do? Well, I've got a multiplication problem. I like a multiplication problem, especially when the output is equal to 0, because then I can use the zero product principle. I'm trying to solve for x, all values of x. So I can split this into 5x minus 2 is equal to 0. Or x minus 6 equals 0. Let's go with the easy side first. I'm going to go with the right side. So if x minus 6 is equal to 0, then I can plug in, I can add 6 on both sides, and that would isolate x. One of the solutions is x is equal to 6. Yippee! Not yippee. I want full credit. Let's solve 5x minus 2 is equal to 0. Well, I'm going to add 2 on both sides. That would get me 5x is equal to positive 2. And then 5x is equal to 2. I want to get x isolated by dividing both sides of the equation by 5. I can leave this as a fraction. 2 over 5, that's 2/5. Or 2 over 5, that would be 0.4. So the two solutions in this quadratic trinomial are x is equal to 6 or x is equal to 0.4. All right, turn the page. 10x squared minus 11x plus 3 is equal to 0. All right, can I factor something from 10, negative 11, and positive 3? Oh, man. No, I can't. I can't do that. So what I need to do is label my A, B, and C. A is 10. B is negative 11. C is positive 3. I'm looking for two numbers that multiply to AC and add to B. In this case, A times C would be positive 30. And B would be negative 11. I'm trying to solve this mystery. Or rewrite history. Woohoo. What two numbers multiply to positive 30 and add to negative 11? Pause the video if you want to figure this out on your own, because otherwise I'm giving the answer in 5, 4, 3, 2, 1. Okay, well, it has to be a negative times negative, because a negative times a negative makes a positive, and two negatives added together make more negative. So if you really want to know that winning team, that would be negative 5, negative 6. Make that a little bit darker for the video to see. Negative 5, negative 6, because negative 5 times negative 6 is positive 30. Negative 5 plus negative 6 would be negative 11. We've found that winning team, but we can't go into that split, we can't go into that binomial factoring yet, because we got to split that middle term. So 10x squared minus 11x plus 3. You take this middle term, and that splits it into negative 5x and negative 6x. And now we've got 10x squared minus 5x minus 6x plus 3 into the rectangle. Ax squared goes in the top left, c goes in the bottom right. Let's put the split bx's in the two diagonals over here. So just for the sake of argument, I'm going to put negative 6x. Oh, sorry about that. Doesn't matter. Oh, my hand is slipping. Oh, boy. Negative 6x goes here. Negative 5x goes over here. Okay, so 10x squared, cover up the right column. Can I factor something out of 10x squared and negative 6x? Ideally, I'd like to factor out a positive. What can I factor out of 10x squared and negative 6x. Well, 10 and 6 are both divisible by 2. And x squared and x both have an x, so I'm going to factor out a 2x since they're both even numbers. Now, I'm going to put the pieces in. 2x times what is 10x squared? 2x times 5x would be 10x squared. 2x times what is negative 6x? Negative 3. 5x times what is negative 5x? That would be negative 1. Check your work. Is negative 1 times negative 3 equal to positive 3? Yes. Therefore, we have factored that quadratic trinomial where a is not equal to 1. So now let's put those pieces in. In the left binomial, it doesn't really matter, by the way. In the left binomial, I've got 5x minus 3. In the right binomial, I've got 2x minus 1. Now then, I've got a multiplication problem. Hey, I like a multiplication problem, especially when the output is equal to 0, because then I can use the zero product principle. So now I'm going to split these two binomials into their separate equations where they equal 0. Put a big old or. I like that big or. So now I've got 5x minus 3 is equal to 0, or 2x minus 1 is equal to 0. Now then, let's solve for the left equation first. I need to undo the layers of x to solve. So I'm going to add 3 on both sides. Negative 3 plus 3 cancel out, leaving me with 5x is equal to 3. Okay, 5x is equal to 3. Now I want to solve for x by dividing both sides of the equation by 5. And if you like a fraction, that's okay by me. You can put 3 over 5, 3/5. If you're a decimal person like me, 3 divided by 5 is 0.6. So either one of these two I will accept. You don't have to put both, just one of them. If you're on team fraction, leave it as a fraction. If you're on team decimal, leave it as a decimal. Okay, 2x minus 1 is equal to 0. So now I'm going to add 1 on both sides of the equation. Cancel out the 1. That leaves me with 2x is equal to 1. And now 2x is equal to 1. I'm going to divide both sides of the equation by 2. And now, if you're a team fraction person, that's fine by me. 1 over 2, that's just 1/2. But if you're a decimal person like me, you can also write this as 0.5. So as long as I see two distinct solutions that are correct, I am very, very happy. So if you like x equals 3/5 or x equals 1/2, that's fine. If you like x equals 0.6 or x equals 0.5, that's fine too. Heck, if you want to mix and match, x equals 3/5 or x equals 0.5, x equals 0.6, or x equals 1/2. I just want to see two distinct solutions that are correct. Okay. I'm looking at the clock. I think we got time for 2 more. We got time for 2 more problems.